Here is a very brief explanation of the example number 10 that is in your notes. Okay, so a student is attempting to determine the concentration of an HCl solution. She uses 0.50 molar NaOH as a titrant, and a phenolphthalein indicator is used. First, she adds 20 drops of HCl to 5 different wells in a well plate. She then counts the number of drops of NaOH required to make this color of the indicator change from colorless to pink. This is the endpoint. In the 5 trials, it required the following number of drops of NaOH to reach the endpoint: 12, 16, 14, 12, and 15 drops. What is the concentration of HCl solution? HCl is hydrochloric acid. NaOH is sodium hydroxide. So let's unpack some information real quick. I've kind of color-coded it here. I know it's a very long problem, but we know that we're looking for the concentration of HCl, right? And concentration is molarity down here. We are given a few things. We're given the molarity or concentration of our base. We know how much acid we are using. We also know how much base we are using, like in terms of drops this time. Okay, we're not going to go milliliters, but drops is still a valid unit of volume. So what we're missing is we're missing the concentration of HCl. So just to recall real quick, the equivalence point is where the moles of acid equals the moles of base. Okay, so putting that into equation, you get this. Now you also remember that molarity is moles divided by liters, right? Well, you can rearrange this equation. You can find the moles is equal to molarity times the volume, okay? Notice that if you multiply this unit by this unit, you'll cancel out the liters and end up with moles, right? So that should make sense. So if we have moles right here, well, this is moles of acid, right? We can find the molarity of the acid times the volume of the acid, and that should actually equal the molarity of the base times the volume of the base. Luckily, we're given, these are 4 things, and we are given 3 of those in the previous problem or in your experiment. So watch out, this method only works for monoprotic acids with monoprotic bases. For example, H2SO4 is not going to be the same because the mole ratio is not 1 to 1. You would have 2 hydrogens here, so the mole ratio is going to be different. Anyways, so the information is now unpacked. We now know that we're going to use this equation, and we know we're looking for the molarity of the acid. And so we know the volume of the acid is 20 drops of HCl, and we know that the molarity of the base is 0.5 molar NaOH, and we know 5 different volumes. So we did 5 different trials. That means we're going to have to do 5 different calculations. Not that bad. It's a pretty simple calculation, but this is exactly like your experiment is set up. So anyways, we have 5 different trials, and you just kind of plug in the algebra, and it's very easy to do. These are very nice numbers and easy to, you could probably do them in your head. But we can get these molarities of HCl. Notice that they're all a little bit different, but about the same. So find the average of all 5 of those. Remember, add them all up and divide by 5, because there's 5 trials, right? And then we have 0.35. Make sure you keep those 2 sig figs here. I kept the 3 sig figs here because I knew that I would just round at the end and get 2 sig figs. So that is the average. Great. But let's go one step further. How confident are we in this? Because we were kind of all over the place, weren't we? We were doing between 12 and 16 drops, right? That was our lowest, that was our highest, right? So how confident actually are we? Well, we can actually put a number on this, and this is called uncertainty, specifically by the halfway method. We're trying to find the halfway point between the highest value and the lowest value. Well, we know that the highest molarity taken was 0.4. and the lowest molarity taken was 0.3, right? So let's find the halfway point in between it, and that is, we're just going to subtract the 2 and divide by 2, and that is going to be our uncertainty. This is going to be 0.1. 0.1 divided by 2 is going to be 0.05. So that means that we're going to take the average, and if our valid range is somewhere between 0.35, let's see, what's that, plus 0.05. So that's going to be 0.4 and also 0.3, okay? So our valid range is somewhere in this area, okay? And that's what that's saying. How confident is that? Well, what percentage of this is of this? You could calculate your confidence in that as well. But just an extension in how your confidence of your results. All right. Have a great day. That's how you work that problem.